This video is going to talk about simplifying radicals, which is a prerequisite skill we need in order to do the quadratic formula. So we're going to start with reviewing how to simplify radicals, and then we're going to go into how that is important for solving a quadratic equation when it comes to using the quadratic formula. So as you can see, it says simplify each of the following radicals. Number 1 says square root of 20. 20 is not a perfect square, and if you're not sure, you can go to your calculator and press square root of 20, and when you hit enter, you're going to see that it's an ugly decimal. This is an irrational number. So if I want to simplify it a little bit, what I can do is go to y equals, and I could type in the number 20 divided by x. The number under the radical is called a radicand, and I take it and I divide it by x just like I do with my factoring trick to come up with the factors of 20. So when I go to my table, I see I have 1 and 20, 2 and 10, 4 and 5. And I say, oh, I'm specifically looking for a perfect square that goes into 20. So 4 I know is a perfect square because I know my perfect squares are 1, 4, 9, 16, 25, 36, 49, etc. Okay, you need to know those. So when you see 20, you're going to break it down into the perfect square first, which is square root of 4, times the other number that's not a perfect square, which is 5. These are connected by multiplication. 4 times 5 is 20. Now you're going to take the square root of 4, which is 2. The square root of 4 is 2. If you're not sure, type in the square root of 4. You'll see that's 2. That comes out of the radical. So it just goes on the outside of the radical. And then what's left inside is the square root of 5, which is not a perfect square. So you just leave it alone. And that 2 becomes a coefficient, and you're done. Let's do the next one. There's a 3 in the front. The 3 in the front is called a coefficient. I want you to leave it alone and just kind of ignore it for now. We're going to try to break down the square root of 80. We want to look for the biggest perfect square that goes into 80. If you do the square root of 80, you're going to see it's not a perfect square because it's an ugly decimal. So go to the calculator, type in 80 divided by x and y equals, and look on the table. Are there any perfect squares that go into 80? 1 and 80, 2 and 40, 4 and 20. So 4 goes in there, but also 16 and 5. So 4 times 20 would work, but you want to look for the biggest possible perfect square that goes into 80. So we're going to pick 16 instead of 4. We're going to do 16 times 5 instead of 4 times 20. If you had done 4 times 20, you wouldn't have been wrong, but you would have had to simplify it again. So that's not your best bet. You want to look for the biggest possible perfect square. So now we're going to do the square root of 16. Hopefully you know the square root of 16 in your head, but if you don't, the square root of 16 is 4. That comes out of the radical. Now there is a random 3 hanging out on the outside. Remember that 3? That's connected by multiplication. So we want to put it back, and we want to multiply it by the 4, which came out of the radical, and leave the 5 inside the radical. And then the last step we do is do 3 times 4 to get the new coefficient on the outside of the radical, and we're done. At the end, you want to look and see, is there anything that you can do with the square root of 5, and you can't, so you're done. Now we're going to do the number 3. We have radical 200. 200, if you put it in the calculator, is not a perfect square. But there is a perfect square that goes into 200. If you're not sure, do y equals 200 divided by x, and you should see that 200 is 100 times 2. Now, before we do anything, some of you may have been tempted to divide this out and get the radical 100. That's illegal because the 2 is not under the radical. You cannot divide it into the radical, so don't do that, okay? Instead, we're going to break down the square root of the square root of 200 into the square root of 100 times the square root of 2. I put the perfect square first, which is 100. The square root of 100 is 10. If you're not sure, go to your calculator home screen and type in the square root of 100. You'll see it equals 10. That comes out of the radical. And then whatever's left inside it, radical 2, just stays There. Now we got to remember that it was divided by 2. So we have to now eventually divide this if we can. So now you're only allowed to divide the numbers that are not under the radical. So the 10 and the 2 you could divide because those are called coefficients. 10 divided by 2 is 5. So this becomes 5 square root of 2. And now we're done. That is your crash course in simplifying radicals. Hopefully you learned that in Algebra 1. Now why is this important? It's important because now we're about to do something called the quadratic formula. And the quadratic formula is going to help us to solve quadratic equations that are not factorable. So one thing that you see in example 1 says solve in simplest radical form. This in italics is always going to be in italics on the regents. It is a key phrase that we need to be aware of because simplest radical form means that your answer is not going to be factorable. It's going to be something that is going to be an ugly decimal or a radical answer. So this means basically this is your clue that it is not factorable and you cannot do anything except what I'm about to do, which is called the quadratic formula. Okay, the quadratic formula is in this box. The quadratic formula is on the reference sheet, which you're going to get during the Regents. So you don't actually have to memorize this formula. And we're literally just going to plug into this formula, okay? So the first thing you need to remember is when I refer to A, B, and C, I'm talking about the coefficients of my quadratic, A, B, and C. So you see A, B, and C in the formula. That's referring to just the numbers in front, the coefficients, okay? So you're not going to plug in x's into this formula, only the coefficients. So if you tried to factor this, I'm hoping you realize that this is not factorable. Okay, there's no numbers that multiply to 4, -4, that add up to -2. So instead, we're going to do what's called the quadratic formula. So first, I'm going to write my formula out. X equals -b. Now, there's actually a song for this. It's the Pop Goes the Weasel. So even though you don't have to memorize this formula, it might help you. So it goes x equals -b plus or minus square root b squared minus 4ac all over 2a. And that's how I remember the quadratic formula because I actually was not given the formula when I was in school, so I had to memorize it. So that was how we did it. All right, so now on the side, I want you to write down the a, the b, and the c. The a is the number in front of the x squared, which happens to be 1. The b is the number in front of the x, which is -2. And the c is the constant, which is in the back. It's -4. This is kind of like when we do synthetic division, we just write our coefficients, remember? All right, now we're going to substitute into this formula that I have here. X equals -b plus or minus square root b squared minus 4ac all over 2a. So everywhere that I'm plugging in an a or a b or a c, I'm putting it in parentheses, okay? So x equals -b, -2. So that's actually going to become a positive. Plus or minus square root, -2 squared minus 4a is 1. C is -4 all over 2a, 2 times 1. So now we're just going to simplify this out and clean it up a little bit. So we have x equals -2 becomes 2 plus or minus square root. -2 squared is +4. Remember, a negative squared is always a positive. And -4 times a 1 times -4, and negative times a negative over here is going to become +16 all over 2. Now, some of you are going to say, some of you may mess up with this, whatever's under the radical. I'm going to circle it in blue here, and I'm even going to highlight it in yellow as well. If you're not sure how to do this math in your head, what I would do is just put the whole thing in the calculator, everything under the radical in the calculator, everything I highlighted except the radical. So I want you to do parentheses -2, close parentheses squared, -4, and then 1, -4. Okay, and when you hit enter, you're going to get 20. So if you look over here, I should have gotten 20 under the radical when I simplified it, which I kind of tend to do by hand, but you don't have to. So this is going to become x equals 2 plus or minus square root of 20. The 20 came from me simplifying all that, all over 2. Now, we have to keep simplifying. You may notice that you have a square root of 20 here. And if you think back to our do now, we could actually simplify the square root of 20, okay? But remember, we're not allowed to divide into the radical. So look, we already did the square root of 20. Remember, we got for number 1, square root of 4, a square root of 5. It became 2 square root of 5. So we're going to bring this back here now. I'm going to pull the radical 20 to the side. I'm going to do radical 4, radical 5, or 2 radical 5, okay? Just a reminder that we have to simplify the radical before we could clean this up. So now I'm going to rewrite this as x equals 2 plus or minus. This is going to become 2 radical 5, which is the radical 20, remember, all over 2. And now you're allowed to divide by 2. You weren't allowed to go in here into the radical and divide that 2 by 20 before, but I'm going to show you what you're allowed to divide. I'm going to circle it in red. It's kind of like a heart. Okay? You're allowed to divide the coefficients by 2. So you're going to get basically 2 divided by 2 plus or minus 2 radical 5 divided by 2. You kind of break it down, give them both the 2, essentially. So we end up getting 2 divided by 2 is 1, plus or minus 2 radical 5 divided by 2. Basically, this becomes 1, and this becomes 1. So you end up getting 1 radical 5. Now, this is the answer. Notice the answer is not nice. It's called irrational. And notice we actually have 2 answers because we have a plus and a minus. So our 2 answers are 1 plus radical 5 and 1 minus radical 5. Those are my answers. So if I were writing a solution set, it would say 1 plus or minus radical 5, or you could list them out separately. So there are 2 x values, but these are called irrational because they're not nice, all right? So the quadratic formula helped us to find the answer. We would not have been able to find this answer using factoring. All right, let's keep it moving. So now it says, when can you use the quadratic formula? It turns out you can use it for any quadratic, whether it's factorable or not, which is kind of nice. So people who don't like to factor, you could actually use the quadratic formula every time. When should you use it? You have to use it when it's not factorable. When the quadratic is not factorable, you must use quadratic formula because you can't factor it. So you got to do something, right? All right, so now let's look over at number 2. Number 2, at first you may say, oh, wait a minute here, this does not equal 0. So before we do anything, we always have to set the equation equal to 0. So before I do anything, I want to move that 10 to the other side to make this equal 0 on the right, to get rid of that 10, okay? So now we're going to have 2x squared minus 2x minus 3 equals 0. And if you try to factor this and use a times c, it's not going to work. You could just trust me on that. You'll get negative 6, and you can't find a multiple of negative 6 that's going to add up to negative 2. So instead, we're going to do quadratic formula. So here we go. I'm going to write it again. X, I just want to hear you to hear me sing again. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's identify a, b, and c on the side. So here I'm going to highlight them. Remember, those are just the numbers in front, no x's. So they're the coefficients, okay? So a equals 2, b equals negative 2, and c equals negative 3. Remember to take the negatives with it if it has a negative or a subtraction. All right, so let's plug in. Here we go. Picking up the pace a little bit here. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So I'm kind of just creating an outline for you based on the formula, and now you're just going to substitute in the blanks, all right? So negative b was negative 2, negative 2. Negative b squared is negative 2 squared. Notice I'm putting this square on the outside, which is important because when you square a negative, it will become a positive. 4ac, 2 times negative 3, all over 2 times 2. So now I'm going to simplify. I'm going to get negative 2 becomes positive 2. And if you want, you could do the trick in the calculator where you just take this whole thing and put it under everything under the radical in the calculator. So do negative 2 squared minus 4 times 2 times negative 3. And we get 28. And again, if you had done this in your head, you would have gotten 4 plus 24, which is 28. Whoop. And then all over 2 times 2, which is 4. And now remember, you can't divide into the radical yet, so you got to take your radical 28, you got to bring it to the side. So I'm going to look at 28, and I'm going to think about the perfect squares that go into 28. I'm hoping you started thinking about 7 times 4. 7 times 4 equals 28. 4 is a perfect square. So the square root of 4 is 2, and you get 2 square root of 7. So that's just on the side how you simplify the radical. And again, that's a skill that we learned in the do now. So now we're going to rewrite this radical 28 as 2 square root of 7. So let's rewrite the rest. X equals 2 plus or minus 2 square root of 7 all over 4. Now what we can do is we can clean this up by simplifying. I'm going to draw the little heart again, dividing both terms by 4. So we're going to get 2 divided by 4 plus or minus 2 radical 7 divided by 4. And what you may note is that the 2 divided by 4 is going to reduce to 1/2. And again, 1/2. So you end up getting 1/2 plus or minus radical 7 over 2. And that is the answer. You could also break it down into 2, but you don't have to. All right, we're going to now do number 3. Notice number 3 is what we call not in standard form. So first thing is I'm going to rearrange these two terms here because they're not in standard form. So I'm going to rewrite it as minus 7x and then plus 10. Now some of you may say to yourself, well, wait a minute, that's factorable. And you're actually right. I'm going to show you on the side. If you did x and x, negative 5 and negative 2, it actually is factorable and you're going to get 5 and 2. Okay, but I want to show you how to do quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So the a, the b, and the c are 1, negative 7, and 10. Okay, so let's plug in negative 7, negative 7 squared minus 4 and 1 and 10 all over 2, 1. Okay, now I'm going to simplify, and I want to show you what happens under the radical. When I do parentheses negative 7 squared minus 4 times 1 times 10, watch what I get. I get 9. And you're like, wait a minute, 9? 9 is a perfect square. So that's true, it is. So you know what happens? You don't actually have to simplify it. You just take the perfect square, and it's 3, right? And then all over 2. And then the last step is we have to get the 2 answers. So we could either do 7 plus 3 over 2, or we could get 7 minus 3 over 2. 7 plus 3 over 2 is 10 over 2, which is 5. And 7 minus 3 over 2 is 4 over 2, which is 2. Oh, wait a minute, look. Look, we got the same answer, 2 and 5. 2 and 5. So I know some of you are like, oh, factoring's easier. Well, it might be easier to you if you know how to factor, but if you're not a good factorer, quadratic formula actually works every time for every quadratic. So this is an idea, okay? Now I want you to try the next page on your own. Good luck.